Pass Marathon Analytics. So we're excited that you could actually join us today for Paul Andrews' session, Beyond IoT Real-Time Data Ingestion with Azure Stream Analytics. This Pass Marathon features back-to-back live webinars delivered by expert speakers from the Pass community. So this session will be recorded and posted online after the event, and you will receive an email letting you know when the recordings are available. My name is Jan Mulkens, and apart from being a speaker at conferences and user groups in Europe, I also organize 2 user groups and a Power BI conference in Belgium myself. So check me out on Twitter to get more information on that. But first, I have a few introductory slides before I hand over the reins to Paul. So, Paul, next slide, please. Thank you. So if you require any technical assistance, please use the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions, and feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. And please note that there will be a short evaluation at the end of the session. This will pop up after the webinar ends in your web browser. And your feedback is actually really important to us for future events. So please take a moment to complete it. Next slide, please. Thank you. So we really want to thank our presenting sponsor, Quest. This Pass Marathon wouldn't be possible without their support. So if you would like to learn more about them and their solutions, please visit the sponsors page in the Pass Marathon website. Next one. Cool, thanks. So you can actually keep learning all year long with Pass. Visit pass.org and check out all of the free educational resources available to Pass members. You can actually just connect, share, and learn with everyone. And this specific Pass Marathon session is presented by Paul Andrew, as I said. And without further ado, here is Paul with a session about Azure Stream Analytics.
Thank you, Jan. So as mentioned, good morning, everyone. My name is Paul Andrew. I'm a senior data analytics consultant here over in the UK. Please feel free to use the social media links and things like that. I sneakily changed the Facebook link that you've got down there on the left. I've actually replaced that one with a link to my GitHub. So the slides that I'm about to send you, there's already a PDF of those in my GitHub repo under the community events. So please feel free to go and grab those if you wanted them. So enough about me, let's move on. Now, I've got my webcam on, so you can see that we've got a big problem here. I'm nearly out of coffee, and it is 6 a.m. in the UK over here. So we'll try and keep the enthusiasm levels high for this early morning session. So Azure Stream Analytics then. So I think we've got a quick poll just prepared. If Jan, if you wouldn't mind just posting that for the lovely audience that we've got this morning.
Yep, poll was launched.
How long do we give them? Fastest finger first?
Yeah, and some people are actually very fast, basically stating they have no idea what it is.
Good, they've obviously had more coffee than I have.
Yeah, we have about half of the people that already voted. I think if we give it like half a minute more, all the rest that didn't have enough coffee yet, they will actually be able to vote as well. Yeah, 80%. So it does seem that you're in for a treat, Paul. At the moment, 80% of the people voted, and 71%, 3/4 of the people, have no idea what Azure Stream Analytics is.
Excellent.
And 29% hasn't used it yet.
Okay, this is good news.
Yeah, I can actually share the results there, just so you see it. Okay, I'll hide it, and it's back to you.
Oh, so no one's using it in production yet. Excellent. Okay, well, hopefully it means that I can perhaps add quite a lot of value then with this session and be fairly informative. So what I want to cover then is firstly setting the scene, a bit of storytelling, the problem that we face, I think, with data these days. Then we'll go into what Stream Analytics is and why to use it. We'll have a bit of a demo and show you some moving data in Power BI. And then we'll come back and look at some production considerations and then a little bit of deeper theory on what the Lambda architecture is. So first off, the problem that we face with our real-time data. Now, once upon a time, I suppose all good stories should start with once upon a time. I think our data was quite considerate. You know, it just sat in our source systems and we were able to go and fetch it whenever we wanted. Not so much anymore. Now, with our real-time data, we just have this pipeline and it just comes in and it just gets fired at us constantly. We don't have a choice about when we fetch our data anymore, it just gets thrown at us. And ultimately, we need to deal with it. We need to have some endpoint to ingest that data firstly. And then once we've ingested it, we need some way to handle it. You know, if we're following the sort of extract, transform, load type process that we might normally go through, well, maybe not extract anymore, maybe just deal with it or ingest it or acquire it with some endpoints. But then we need a handler, as I've called it in this slide, or a means of perhaps transforming or doing something with that real-time data. And with Azure Stream Analytics currently, we can do that in 3 formats: JSON, Avro, and CSV. Our other formats aren't currently available yet, but just, I say, something to try and bear in mind. So that's our problem. That's setting the scene then. We need a way of handling this real-time data as it comes in. So hopefully that's enough of that. So let's now actually look at what Stream Analytics is and why to use it. And what I tend to do firstly, as you perhaps might have already done, I'll just Google Stream Analytics or another friendly search provider, and I see what Microsoft has to say about it. And normally their website, it's perhaps written by the marketing people, but you know, it's fairly good. And as you can see here, it's an on-demand real-time analytics service to power intelligent action. I mean, that sentence alone just makes me think I just need to use this. You know, I feel empowered by that. So that's good and that's okay, and that probably tells us a little bit about it, but it doesn't necessarily give us perhaps the information that we want as technical people as to, you know, what is it going to be used for, what does it do, and why is it going to be used. So for that, I want to try and put Stream Analytics in context. And the way to do that is to talk about what we would call a data as the modern data warehouse. And what we get within that modern data warehouse is something that looks a little bit like this. This is just a very generic architecture diagram of how something might work in Azure if we're using a modern data warehouse type architecture. All of the tech, or most of the tech on the screen here, it's all Azure tech or platform as a service stuff. And you can see that we've got Stream Analytics sort of in the top left-hand area as a means of ingesting that data before we persist it to storage, before we do anything with it, you know, before we create our semantic layer. It sits there alongside its batch data. The batch data that in this case is being loaded maybe from an on-premises SQL instance or wherever, and Data Factory is handling that for us. So I say hopefully that just gives a little bit of context. Now I appreciate I've not answered what it is yet in my words, but I think that context is firstly perhaps important to know that Stream Analytics is there to handle those real-time feeds and maybe to complement the wider data warehouse architecture that you might have. So let's backtrack a little further, and let's also just think about those endpoints, those means of actually ingesting that data. Now, we have two options here. We have an IoT hub on the left, and we have an event hub on the right. So just a few quick comparisons as to why we might use one or the other. I'm not going to read out the contents of this table, but the main things that normally I ask of my customers if they are looking at these means of ingesting that real-time data, firstly is, do you want the two-way traffic? Are you interacting with a device, or is it simply a service or something like that that is sending the data to you? So you don't necessarily need that bidirectional traffic through that endpoint. Scaling is also a factor, and then typically security becomes a factor in those conversations as well. So I say backtracking slightly, but I think it's important firstly just to understand those endpoints and where we actually can ingest that real-time data in Azure. And of course, my title, I'm talking about beyond those IoT real-time data streams, and then actually what comes next. So if I just come back to my modern data warehouse, and we've talked about those endpoints there, those hubs that can act as the funnel for our Stream Analytics service. And you'll perhaps notice I've compared them as perhaps using one or the other, but then in this diagram, I've got one feeding into the other. Again, it's just an architectural decision there. Do you have lots of devices that perhaps you want to separate out into different event hubs, different IoT hubs, and then maybe you want to combine them into a single stream with an event hub after that? You've got that flexibility. You can use both, you can use one or the other. It's very much dependent on your requirements. So enough about the endpoints. I guess the main reason for being here then is to talk about the next thing along. So in this diagram, Stream Analytics. So what is Stream Analytics then? Let's come back to that question. And the way I guess I'd like to describe it to you is that quite simply on the left-hand side, we have our inputs, as we've already talked about, and then on the right, we have our outputs. And we get this stream of data coming in. Now, typically this might be a JSON message, and this message will just flow through the Stream Analytics service from left to right. You're going to love the PowerPoint animations. We're going to go a lot more advanced on those animations. And what we get in the middle is a query. And I guess the best way to try and think about Stream Analytics and to describe it is, for people that have been working with batch data, we have that data loaded, and that data will sit in our database, and it will pretty much be static until we do our next load. And what we'll do is the data will stay the same there, and we will change the query for whatever we want to bring back from that data set. The opposite is kind of true here with Stream Analytics. So with Stream Analytics, we will define this query that sits there at that point in time. And then as that data comes through, that query will stay the same, but that query will then output whatever it's asked of it as that data is streamed past it. So I say just a slightly different flip in mindset there. With our batch data, the data stays the same. Our query will change as we want to do things with it. With Stream Analytics, it's the data that is changing or is being streamed past, and that query stays fixed. So you can see from the query on my screen, it uses this SQL-like syntax. I have very much an internal argument with myself as to whether that's a good thing or a bad thing. It's nice, and it makes me feel comfortable that it looks like T-SQL, but then I guess it kind of behaves in a slightly different way. And I'll try and talk about where those differences are and why as we go through. The other thing that we can do here from our inputs is not just the inputs from our endpoints for that real-time data, we can also have a static input. So if we want to join some reference data into our query, so in this case, I've added an inner join here from maybe a products lookup, and I'll show you this in my demo. So that data set can sit in blob storage. We can ingest that, and we can use that reference data with our streaming query as it goes through. There is currently, I believe, 100 megabyte limit on that reference data. So, we're not storing huge dimensional data sets in here to be used with the stream, but it's just another option. So let's think about that query itself then. And I've described it as this query that's fixed as that data moves through. Well, what's actually a better way to describe it, or another option that we have available in Stream Analytics, is that that query can become a window. So it's not just a fixed point, but it's a window of time. And we have three options for this. We can define a sliding window, a tumbling window, or a hopping window within our Stream Analytics job. And again, Microsoft link here in the bottom left, and this window, as they describe it, contains event data along that timeline. I say perhaps a nicer way to phrase it, but hopefully with this stream of data coming through and that window that we've defined, it will help you understand. And again, I warned you, using the power of animations, here is our sliding window coming in. Look at that, isn't it glorious? Oh, there's no audience laughter. I'm sure you're laughing. Next, our tumbling window. So really, I say the point is just to understand the differences. And with our tumbling window, that will jump forward in time, giving us those outputs for each of those tumbles. The tumbling window, I guess, Microsoft have, I think, tried to unify some of their terminology now. So for me, in Azure Data Factory, we also have this concept of a tumbling window, which got renamed from time slices in Data Factory. Same sort of idea for that time series data, if you like, loosely applied to this situation. Lastly, our hopping window. So the difference between tumbling and hopping windows is quite simply that the hopping window has an overlap between its previous window. So three things to bear in mind, three windows that we can define for our Stream Analytics query. And those windows help us with our aggregations that we might want to perform. Slight caveat that a window can only have a maximum duration of 7 days. I think, is that really a limitation? I think if we're having a Stream Analytics query window that's 7 days, then I think really that should perhaps be a batch data load rather than something that we might even consider real time. I certainly wouldn't say, oh yeah, you've got a real-time feed that's 7 days old. I don't think that works, but I guess just bear that in mind. You might have a particular use case. So hopefully that informs you as to what Stream Analytics is. Say three main parts: the inputs, the outputs, and then we've got that query in the middle. And it's that query that becomes quite powerful. It's that query that we can use to do some quite advanced things with our real-time feed as it comes through. Now, what perhaps is missing from this architecture diagram that I'll come back to is that here we have Stream Analytics feeding into Azure Data Lake, and that's very much just being landed to be used with the rest of our layers. What we can also do, which is quite nice, is that Stream Analytics service, if I just get my laser pointer on the go, hopefully that's maybe displaying, our Stream Analytics service can also feed directly into Power BI. So queries and things that we write and we create within our Stream Analytics service, they can be fed directly into Power BI and then represented as live streaming tiles within our dashboards. So, this is quite a nice feature that really is what I now want to show you, I guess, very much in the form of a quick demo, and say hopefully just to try and back up some of those things I've talked about with that service. So for my demo, what I've got, I've cheated slightly and I've created a real-time feed from our AdventureWorks database. And I've got the OLTP version of the AdventureWorks database, and in here we've got, as you may already know, an order details table. which if we just do a quick select from, again, probably no surprises, but we've got a bunch of stuff in here about products and orders, unit prices, and so just some data. Now this data is going to be the input for my Stream Analytics service. And what I've done is, this of course isn't naturally it's not naturally a data source that lends itself to this real-time feed. So what I've done is I've kind of artificially created that real-time feed using this data source with a little bit of C#. So in Visual Studio, I've got a fairly simple app that I'm just going to run shortly, and this is going to hit my AdventureWorks database. It's going to randomly select a line from that order details table, and it's just going to bring that back, turn it into a JSON message, and fire it up to an Azure Event Hub. So I'm using this C# app, if you like, to infer or create that real-time feed just for the purposes of this demo. So let's just kick that off. This is where everything goes horribly wrong. So this, as you perhaps saw in the code, this is just looping over, hitting that database table, returning a row and sending it off to my Event Hub. So nothing too exciting at that point. So now let's just jump into the Azure portal. And what I've got here is a dashboard. In my portal, I've got that input on the left-hand side in the form of that AdventureWorks database. And I've then got an Azure Event Hub defined with a namespace. And you can see that I've now got these messages feeding in. So just that endpoint service that my C# app is authenticating against, and those messages are being fed into it. Then the next thing I've got is my Stream Analytics service in the middle, which if we have a look at, we've got those three components in there that we need to define. So firstly, we've got our inputs. You can see that I've got that input from that Event Hub. And if you're working within the same subscription, you can very easily add this input, create it, and it will look for the Event Hub service that you've already got deployed. You can tell it that yes, ingest it in JSON form, and that will work for you. What I've also got, and what I alluded to in my slides, is I've got an input from blob storage in the form of my products dimension. So what I've also done is, from my AdventureWorks database, I've taken the products table, I've got it as a CSV file, I've put that in blob storage, and I can then use that as reference data as an input for my Stream Analytics queries. So that's my inputs. Outputs, I have I'm only using two of these. I've got one to Azure Data Lake. So I'm just kind of passing that data through and persisting it in that data lake storage. And I've got an output also to Power BI, which is where we can have a little bit of fun with those real-time streaming tiles. Then lastly, in the middle, we've got the glue, or we've got the query that's going to do the work for us. So if I just have a quick look at this query that I've already got defined, it's slightly grayed out because the Stream Analytics job is now running. It takes a few minutes to start up, so I obviously wanted to have this done before I showed it to you. What we've got in here, you can see I've got one query defined that is doing the pass-through to Data Lake. And what you'll perhaps see is that the query is going into Data Lake, which is the output, and it's coming from my Event Hub. So, it is like T-SQL, but say there's these quirks when we actually use it. So into is now the clause that we use to define our output for the job. Then below, I've got a second query defined, which is doing something a little more interesting, similar to my slides. This query, we've got our output to Power BI this time. It's coming from my Event Hub, but you'll see I've also got a join here to my dimensional data, to my products reference data set. So we can bring in that product name as part of this query. We've got, whoops, wrong one. I've got a bunch of aggregations defined and then some grouping. So hopefully, a fairly straightforward query for anyone that's familiar with the T-SQL. The interesting thing about this in the context of Stream Analytics is I'm defining a sliding window of 30 seconds. So that data is going to come in, it's going to perform these aggregations on that 30-second window, and then it's going to give me those outputs. So something, say, that we can only do in Stream Analytics here is defining those group by windows to actually do those aggregations grouped by that window. So that's the nicest thing about Stream Analytics, perhaps the main reason why you might want to use it to do those aggregations as this data comes in. So that job is running and it's now started. I hopefully still have my app firing data into the Event Hub. Good. So firstly, let's just look at the boring outputs in Azure Data Lake. So in my Data Lake storage, I've got this folder structure which was defined as part of the output in the Stream Analytics job. I've got my month of November, I've got today, and I've got a single file. So what Stream Analytics will do with the folder output that I've defined in my job, if I just drop back to the portal and just quickly look at that output. So you can see in the values for this output, let's just get Zoom on the go. You can see I've defined that structure and that date format. So it knows how to put that data into my data lake store. And I've got this file which will now, it will collect all data within that file for a given hour. So hopefully if that's not too large, I can just double click and it will download that one for me and open it, which has gone onto the other monitor. So what it's put into my data lake storage for me is a single file representing the current hour, and I have a line per JSON message that has come in. So every line in here is one message from that app. So one random row from our AdventureWorks database has come in here as a line in this data set. So obviously that's one option when we want to start using this and if we want to persist that data to some storage. Let's just go along here. So you can see as well, one thing that Stream Analytics does is it adds its own fields to the data set. So it gives you its own information about when the event was received, when it saw the message coming through. So regardless of what data is in that message, it also appends its own attributes. So just to prove I'm not cheating here, we do have the Event Hub UTC time, which is 6:27, which happens to be the same as my local time. So that's our boring data lake output. Now let's have a look at Power BI, because this is mostly where things get a little bit more fun, and it's where you'll generally get the buy-in from the business if you start telling them that you can have live tiles in Power BI. They love it. So I've got a blank dashboard, and I'm just going to add a tile, and what I can do is I can use this option when I click add tile for custom streaming data, and I've got a AdventureWorks stream output defined as the data set. And what I'm going to do is firstly bring in a clustered bar chart, and I'm just going to have the product name, which is going to come from that dimensional data set in there, and I'm just going to bring in the order quantity. And let's just get rid of that. So nothing too fancy, but we can ultimately see this one moving. Then let's bring in another tile, and let's have our data set again. Let's have a live chart this time, and I'm just going to put the event date time on the x-axis, and let's just now put unit price on there. So this isn't a talk on Power BI by any means, but really it's showing you that we do have these real-time capabilities for our Stream Analytics job. And what I've got is in my app, you may have noticed I also dropped in with my Pigeon C# skills, I also brought in a form in here as well. And this form is just defining the iterations in terms of how many messages are sent per second. And of course, this is hitting our AdventureWorks sales database. So, you know, it's quite nice that we can just say, send me more messages more frequently, which then obviously affects our charts that we've got in Power BI. You know, if I assume that most salespeople would want a sliding bar just to increase sales like I've got for my app and my messages here. So you can see that this is getting a bit more spiky, a bit more movie as I start firing those random bits of data through. This is obviously all fairly meaningless, and I'm sure there may be duplicates coming in here as that table isn't very large, but I guess really the point is to understand that from this input and from this output, we have that Stream Analytics glue in the middle that is doing that work for us. It's giving us that ability to do this aggregation over that real-time feed as it comes in. And bear in mind, as I said before, that query is fixed. It's the data that's moving past it. So let's maybe just like dial this down maybe to like every 10 seconds. And bear in mind that the sliding window I had was for every 30 seconds. So it's now my line chart is perhaps going to flatten a little bit as I've dialed down the number of messages that are coming through here. So hopefully I say a fairly fun example, but something that's hopefully meaningful and hopefully gives you a feel for why you might want to use Stream Analytics to achieve something with that streaming query that's a little bit more interesting. So next then, what I want to do is I'm just going to stop my Stream Analytics job so it doesn't use all my credit. I now just want to drop back to my slides, and with that in mind, it always goes on the opposite monitor. I want to talk about now just some considerations for you guys. So you know what Stream Analytics is now, and you've seen it in action in that demo, and you've seen how one output can work to Power BI. That's quite nice. And I guess if we want to try and define the architecture of my demo, it was something a little bit like this. I appreciate it wasn't necessarily from an on-premises source. It came from an AdventureWorks database that happened to also be in Azure for my example. But this was loosely what we had for my demo. And what I want to do now is just talk a little bit more about some of the architectural decisions you might want to make if you are going to start working with Stream Analytics in your solution. So firstly, I had a single Stream Analytics job that was ingesting my data, and it was sending it out to Power BI and Data Lake Store. And I had two queries within that Stream Analytics service, which worked fine. What I would perhaps say to you is that in a production environment, you might want to consider decoupling those streaming jobs. So maybe you have one streaming job that sits there as a pass-through to your storage if you want to persist that. And then maybe have a second Stream Analytics job also consuming the same data from that event hub, but maybe the second Stream Analytics job is now doing those aggregations. It has those sliding windows. And this, I guess, gives you that flexibility in production where you can control the persisted job as well as maybe changing the queries in your aggregated streaming job, the second one that's on screen there. So first consideration, and I guess the other thing to note here is that if you're doing outputs to Power BI, you will need to define multiple outputs in the Stream Analytics job if you want to have multiple aggregated queries all going to Power BI from Stream Analytics. So I guess to try and tighten that sentence up a little bit, if I have one query in my job doing an aggregation with a sliding window, that's one output to Power BI. If I have a second query that's maybe doing a tumbling window, that's another output that we'll need to Power BI. So again, just kind of bear these things in mind. We can have multiple queries. They might need separate outputs depending on what you're doing. Maybe also think about decoupling them with multiple Stream Analytics jobs. So that's the first thing that I want you to think about. Next, let's think about if we don't want our data to be sent to Azure via the public internet. But, you know, perfectly rational. If we've got some security conscious people, they might say that, okay, I'm going to send my data up to Azure, but I'm going to use a VPN. Now, if we're using that VPN and we've got that private network, that's going to have ultimately a Azure VNet that accompanies it. And what's currently in preview for our Event Hub service is the ability to have a service endpoint. So that service endpoint associates or connects our Event Hub to that VNet. And when it does that, the Event Hub loses its public endpoint capabilities and it now gets a private IP address, which is fine. Now, the consideration here is that actually with an Event Hub service endpoint, that's not going to work via a VPN connection. You will have to pay for an express route for that to work. So hopefully just modifying the slide there, you will need express route if you want to fire data up to your Event Hub and have it consumed with that service endpoint in place. So I say just another slight consideration there, depending on how you want to work. Now, let's pretend you're rich and you can afford an express route. That's fine, we can bring that in. But the problem we've then got is that our Stream Analytics service doesn't currently support service endpoints. So if you add an input to your Stream Analytics job from that Azure Event Hub that has its service endpoint, Stream Analytics won't be able to talk to it. So that's going to cause you a problem. So, you know, that's probably going to crush any sort of argument you have if you want to send data via that private network connection. Stream Analytics isn't going to work for you. Now, you could say, what else is going to be using service endpoints? And at that point, yeah, we can say our outputs. So if in this case, our outputs are SQL DB and our outputs to Azure Data Lake, they do support service endpoints. So really, for me, there's definitely we need to sort of bang on the door of Microsoft here and say to them, please enable service endpoints for Stream Analytics. That just means we can keep things all within that private network. So really, I guess in this architecture that we've got on the screen, we can't use Stream Analytics, which is a problem. We do think that endpoints are coming soon, but not yet. So let's move on. Let's think, okay, you know, I'm not deterred. I still am going to use Express Route. I'm still going to use Event Hub. It's going to have its service endpoint, but really all I actually want to do is write my real-time data to data lake storage. I just want to persist it, nothing more. I don't want Stream Analytics in the picture at all. And if you do that, then that's fine. You can use a feature of Event Hub called Capture. Capture allows you to just persist that data as it comes in and write it directly to your data lake store, which, you know, may work for you. It may mitigate the need to pay for Stream Analytics. So fine. That said, there is some limitations here. So when you define the folder structure that you tell it where to put the data in your data lake store, it's certainly not as flexible as what I showed you with my output from Stream Analytics. You will have to inherit things like the partition number and other bits and pieces there that you have to use when it comes to bringing that data into Data Lake Store, which means perhaps if you're then consuming it in Power BI, you're not going to have that live tile capability. It is very much just going to be hitting Data Lake Store with that connector and reading that data very much in a batch form. So, you do have this ability to capture straight away if you like, but perhaps it's not necessarily why you would want to use Stream Analytics. Anyway, let's pretend we're not deterred by that, and I think I'm defiant here. I am going to use a real-time feed of some sorts, and we know we can't do this with Stream Analytics at the moment. So perhaps we enable Kafka on our event hub, and let's maybe think about, instead of using Stream Analytics, let's use Databricks. And let's use Spark streaming to achieve the same thing, which would work for you, because Databricks has its cluster underneath. It has the ability to talk to a VNet, and we can potentially peer the VNet that our event hub is using with the VNet that Databricks is using. Now, personally, we've had a few problems in doing that. I don't think that there's a few bugs there with that working at the moment. But also, what you want to bear in mind is that when that peering is in place, if that Databricks cluster gets deallocated or it turns itself off, that peering is going to be lost, because the address spaces that are underneath it, when the cluster goes down, those address spaces in that Databricks VNet also go away, which means it breaks that peering. So a slight frustration that we have at the moment. The other consideration here, if you decide to go with this architectural approach, is that Databricks, perhaps as a cluster, it's going to request a minimum of a worker node, or a minimum of one control node and perhaps two worker nodes. So that cluster, that infrastructure that sits under there, might be a little bit more expensive than the equivalent Stream Analytics service and the VMs associated with those streaming units. Lastly, with this one, that Power BI connector, that's actually only going to hit the Databricks DBFS. So it wouldn't, again, give you those live tile movements like we had from Stream Analytics. So I say you can still achieve that streaming throughput if you want, perhaps, but not necessarily in the nicest way that we had with Stream Analytics. In terms of VNets, as we mentioned before, we do have those capabilities from our SQL DB and from our data lake store. So achieving that, very much closed private network is certainly possible. So a few considerations there, and just to, I guess, summarize, let's bring all the lines onto the picture so you can have a very crazy diagram. But again, I say, just to summarize, let's bring those things back in, and let's actually think about some of those, say, production considerations. You know what Stream Analytics is now. These are the things you perhaps need to think about depending on how you're going to architect your solution for your customer or whoever. Great. So what I want to do is then, lastly, I just want to touch on this idea or this concept of a Lambda architecture. I suppose maybe a poll would have been nice just to ask who's aware of it, but I think given the first one, we'll just crack on. So a Lambda architecture, I say, just a final thing here for you guys to think about, is it's this idea of having our batch data and our streaming data together in some process that means that we can use both of them. We can balance latency as this chap Nathan Mars talks about in this big data book in pages 14 to 20, I think, when I checked. So do have a look at that book. It's a very good book in general, but this is perhaps a good introduction to the Lambda architecture. I'm obviously going to give you my version now. So what we have here is we have our data coming in, and then what we'll do is at a given point, we will perhaps run our ETL, our processing, and we will do that batch load. Now, while that's happening, our data is still coming in, and after our batch processing is finished, we do get that output. But this data is, it's still coming in. We run our batch load again, and we get another output. But again, all the time, this data is still being born at source. And, this process can carry on, which doesn't really work for us because it means that we only have the ability to query that data after the batch processing is finished. Now, depending on what your ETL window is, you're only going to have access to perhaps those first bits of data in this situation, just because you've got to wait for that batch processing to complete. Now, the solution here is that data can come in and it can be handled by our batch loading, but then we have this second path, this second set of technology for our streaming data. And it means that we can query both that streaming data and that batch data at the same time. And the way that we do that, or the way we can think about that, or maybe the way Nathan Mars describes it in his book, is that we have this batch layer and this speed layer, and then on the end of it we have a serving layer, which means that we can access both that streaming data and that batch data at the same time through this serving layer, which means that our query has all of that information. We can use it all at the same time. Now, so that's the theory behind it. If we want to talk about the tech and how that's going to work in the world of Nathan Mars, when we're doing things open source, we might use some of these services. We might have Storm in there for our speed layer, and we've of course got Hadoop doing our batch processing things. Perhaps not so much as we're working in Azure. In Azure, we might want to change that technology slightly, and what we would perhaps do if we were developing this for the customer is have the batch data coming in, maybe landed in Data Lake Store, and then maybe using Databricks to do that transformation work, and we might use SQL Data Warehouse as that serving layer. I guess in reality, or what actually gets created there if we're doing this is in our SQL DW, we might have a physical table that has been loaded from Databricks that handles our batch data, but then maybe we might have an external table defined as well. So maybe cheating slightly here by persisting that data from that streaming path into Data Lake Store as well, but this time using that external table, using those poly-based capabilities from SQL DW to, and then maybe a view over the top of that physical and that external table that then gives you the ability to query both. So that's perhaps one option that we might have if we're working in Azure. If this idea of a Lambda architecture is new to you and maybe a little bit deeper than you want, my colleague Simon Whiteley, he did a session on just the Lambda architecture at the PASS Summit this year. So maybe if you've got the recordings for that, maybe check out his session. He might inform a little bit more detail about that Lambda architecture. I guess the last thing I want to touch on here is that with that speed layer, again, we don't have to use Stream Analytics. As mentioned in my other considerations, we could also use Databricks to deal with that work as well for us. So again, just a few options, and I feel like I'm not necessarily doing Stream Analytics justice with my talk by talking about all the alternatives all the time, but I think you need to know this. So I guess then really just to wrap up and try and come back to my modern data warehouse here, because I've kind of talked about and shown a few things that I guess aren't represented here. So just wanted to touch on them again. So we've got our endpoints, our IoT hub and our event hub bringing that data in. And here we've got Stream Analytics that's perhaps persisting data to that data lake store. Now, we could say that in this generic diagram, we have maybe a Lambda architecture type approach. We do have that batch data coming in, and we could potentially have the speed layer and the batch layer represented in our SQL DW as the serving layer over on the right-hand side. So, I think this is perhaps fairly well represented. What isn't, of course, and what I've mentioned is that Stream Analytics can also output directly to Power BI. So it can sit there as that handler, as what I described in perhaps my very first slide when I talked about it. It's that handler for those real-time feeds, and we can do quite a lot with it, with those aggregations, with that flexibility, persisting it to storage, using it as a means to produce a Lambda architecture, whatever we want. So just wrapping up, hopefully that's covered everything that I had on the agenda there. Let's just put some ticks. I guess thank you everyone for attending. As mentioned, the slides and things are in my GitHub repo, and I think we've probably got about a few minutes for questions if anybody has any.
Well, awesome presentation, by the way.
I'm going to imagine that everybody's just clapping in the background now.
Yeah, everybody actually was clapping. I was hearing it on the microphones. Ah, ball, yeah!
Thanks.
It's early. Hey,
Yeah.
during your presentation, when you had the query sliding window thing, and you're basically accustomed to having live feedback from the audience.
Yeah.
You said oh, I imagine everybody's laughing. Well, people were actually laughing. Somebody commented, "I'm laughing. Great animation, lol." So
Great.
there you go.
It's always a disadvantage with a webinar.
Sorry?
Always a disadvantage with a webinar that you don't get that audience feedback.
Yeah, but you did great. Leonardo also asks if you can tell us a bit. Oh, the questions are coming in like crazy right now. I need to scroll a bit. So Leonardo asked if you can tell us a bit on the pricing of incorporating Azure Stream Analytics.
I hate the pricing questions. I'm going to go with the consultant's answer, Leonardo, of it depends. It depends on how much data you're dealing with, how often you're ingesting it. You have the scaling of your event hub to think about, as well as the streaming units that you define for Stream Analytics. The cost calculators are out there, so I guess really I would suggest just suck it and see. Really is all I can say. It's not expensive. So I've left that streaming job running in my Azure subscription. It's not cost loads, so give it a try. You can have an IoT hub, I believe, for free still. So there is still a free tier for that. It's just a compute and I think ultimately the virtual machine that sits behind Stream Analytics that'll cost, but it's not expensive, certainly for small volumes of data.
Usually what I tell people is just set up a small proof of concept.
Yeah, exactly.
Make the calculation from there.
Yeah.
Yeah. So Andrew is interested in knowing if you've ever tried visualizing a large number of sensors using Power BI from Stream Analytics on the live tiles.
Not a large number of sensors, no. I know that the Power BI dashboard, it does have a few limitations in what it allows you to visualize. I've certainly had issues when I've demoed it in the past where it tries to sort of intelligently detect the bandwidth that you have, and it then makes a decision about when it can produce those live tiles for you, and it does things like that in the background. So I guess if you've hit some limitations on how much data you're trying to visualize, I'd be interested to know about that.
Yeah. Okay. So yeah, he basically gives us an example. If you have 100 real-time temperature sensors, it can seem that to be possible to actually visualize. But my advice would be don't visualize 100 real-time sensors at the same time. You probably want to visualize some averages of that.
Yeah, absolutely. Yeah, so definitely do break out those query windows and yeah, do some aggregations and probably try it now in Power BI Desktop, which also supports those streaming capabilities now too.
Yeah. Callan is asking if there are any connections between Azure Stream Analytics and data flows in Power BI.
Not that I'm aware of, no. They're still two fairly distinct technologies in my mind. I've not come across any overlap, and to be honest, I confess I've not looked at Power BI data flow a great deal I guess, to be able to draw a fair comparison there.
Yeah, neither have I. Well, that's about everything of questions. So
Great stuff.
I guess we can both get to work today.
Yeah, I'll go and get rid of the bedhead and actually start my working day now. So it's 7 a.m. Local time for me.
Yeah, we still have some slides to wrap the webinar up. The question slides for one, and then another one after that.
Oh, do we? Oh, I haven't got those.
Oh, okay, too bad. Well, either way, everybody who's on the call, there is a new pass marathon coming up, a developer edition, and it starts on at 1500 hours UTC on December 12th. So you might want to check that out if you're interested. All the information is on pass.org anyway. And I suppose, unless Andrew has anything else to say, we really just want to thank you for being here.
Yeah, yeah. Thank you everyone for attending. Thank you for listening. Do reach out on Twitter or email me or whatever if you do have any follow-up thoughts. Thank you.